I am going to be ranking functions according to my own personal tastes, basically, and I'm going to be sorting them into the categories of favourite, yes, maybe, and no. Now, some people might find these rankings particularly sus, but that's on them, not me. Let's start with the successor function. The successor function takes a counting number and returns the next counting number. So you give it 0, you get 1. Give it 1, you get 2. This is the basis of all mathematics dealing with counting numbers. And in turn, it can be thought of as the basis of all number-based mathematics. It is the fundamental of the infinite set. All of mathematics sits on top of the successor function in a way. It is fundamental. It is useful. Despite all that, it's not that sexy. So I'm going to put it into the category of yes. Modulus, on the other hand, returns the value you would get as a remainder when you do a division. It is super useful for programming because it allows you to do values that sort of sawtooth up. You can do things that repeat and come back to 0. You also can think of it not just as a map between counting numbers and counting numbers, but also as a way of mapping a counting number onto a finite group. I think the mod function is one of my faves. The next one is a little bit odd as a function because it is the differential function. This function takes another function, so it's a second order function, which is already very fun and useful, and it takes that first function and it differentiates it. So I think that the differentiation function is going to be another one of my faves. So we'll put it up into the fave group. Along with the differentiation function, we have the integration function. And honestly, I don't like integration. Differentiation function, when you differentiate, you can put the differentiations together and they obey lots of neat little laws. Like you can have the product rule and all of that, and the power rule and the compounding rule. But integration doesn't obey all those rules. And it's always messy and it always has to rely on you doing things and solving them, and it's just a mess. Integration is just a mess. So I'm going to put that one into maybe, because while it's a mess and while it's ugly, it is still very useful. Our next function is the universal Turing machine, which you don't normally think of as a function, but it is actually a function from a Turing machine to a different Turing machine. The universal Turing machine can emulate every other Turing machine and is the fundamental basis of all of computer science. It is definitely one of my faves. And while we are doing the universal Turing machine, we also have to talk about the universal Lambda operator, which is basically the universal Turing machine but for Lambda or Lambda expressions. And you can actually say these two are mathematically equivalent. So for those reasons, it is also a fave. In fact, I like it better than the universal Turing machine because I'm more of a functional programmer than a procedural one. The next function is omega, the Turing oracle. This function takes a Turing machine and the input to a Turing machine and tells you if it would halt or not. Turing oracles can't be done by computers. It is a non-computable function, Turing oracles I've read, and I haven't fully understood the proof for this, so I might be misunderstanding it, can actually violate the second law of thermodynamics. As Homer Simpson said, we do not violate the second law of thermodynamics in this household. Turing oracles are a definite no. The identity function. The identity function takes an input and returns that value exactly unchanged with no modification. It does nothing. So you might think it would be a no or a maybe because it's useless, but it's useful in so many places. And it has every value to the identity function is a fixed point. Also, it's not one function, but a whole family. So I am going to say yes to the identity function. The next function is the Raymond Zeta function. This function has a whole lot to do with number theory and complex math, and finding non-trivial zeros is a $1 million prize, etc. It's very famous and all that. It's also not involved in any mathematics that I'm interested in, so I'm going to put it into maybe, but this is more a personal thing. The fixed point function. Now, the fixed point function takes any function between the same type and returns a fixed point from that type. In domains like the Lambda calculus and Turing machines and all that type of thing, the fixed point will always return a value. I love fixed points. They're very important to my philosophy and to me as a person. That's definitely another fave for me. Map. Map would be in the fave category. Map takes a function that operates on a single value and lifts it up and turns into a function that operates on an array of values. I've done a video on MapReduce. You would think this would be a fave. However, it's got a problem. It's called map. There are too many things called map. This is irritating to me. I'd love a better name. If it had a better name, definite fave. With that name, I can only put it into yes. I'm sorry, map, but that's the way things roll. Next one is fold, otherwise also called reduce. This takes an operator and converts it into a function that takes an array and returns a single value. There are a couple of variants on this, like map R and map L. They're not important. Unlike map, fold has a good name. Reduce is also a good name. It's got two good names. Map/reduce, going into fave as well. Log. I like logs. When I discovered logarithmisms as a high school student, I fell in love with them. Not just because they're useful, but because they convert the domain of multiplication into addition. In a way, they are a mapping between those two groups. So, log, definitely in the yes category. The discrete logarithm function has all the things going for it for logs, but also is uncomputable. Well, it is computable, it's just not computable in an efficient way. And because of that problem, because the discrete logarithm problem is difficult for computers to solve, it is actually the basis of several bits of cryptography. Great fields of public key cryptography and other things like that that rest on the difficulty to compute the discrete log problem. Because of that sheer utility and some of my background in computer security, discrete log, fave. the exponential function. So this one is basically the reverse of the logarithm function. It's useful, not as sexy as log, so I'm going to put that into maybe. Exponential function, but to I. This is a really favourite function for many people. It's definitely more sexy than XPI, the exponential function. So I am going to boost it up into the yes category. Also, without that, we wouldn't have Fourier analysis. So that is a definite plus. I've got sine here, but it's sit in for all the trigonometric functions. Yep, they're useful, they're helpful. We've already got AXPI on the list, so that's almost redundant. So I'm going to put you into maybe the absolute value function, or possibly the function that returns the, what's the name for it? It's the function that returns the number of numbers of something. Apart from the fact that I can't remember it, also very useful. Gets rid of negative numbers, tells you the magnitude of something, embeds within it Pythagoras' theorem. Definitely a yes. The constant function. This one's a little tricky. No matter what value you put into it, it always returns... cardinal, thank you. I knew it was that. The constant thing always returns the same value no matter what you put into it. It is terribly useful. A lot of the functions, find a function that will fit into this gap, get trivially solved by just using the constant function. It's one of those little tricky ones. So, I like it. It's got spunk. I'm going to put it into the yes category as well. The floor function, and in here I'm also going to include its brother, the ceiling function. It's not that thrilling, it's not that exciting, but it's useful. I am going to put into maybe the empty function. This is the function from the empty set to the empty set, and is made up of the empty set. It is beautifully pure in doing absolutely nothing. The identity function made no changes. This makes even less than no changes. I just like its pure aesthetic, not just aesthetic, but aesthetic nature. Definitely. Fave. Tupper's self-referential function. This one is brilliant as well. This function, if it's run and graphed, will print out a dot matrix drawing of the function itself. I love that. I love fixed points. I love transformational fixed points. If you have something coming in a loop and coming back to itself, yes, this makes me thrilled. I love this. Yeah, definitely fave. Okay. I'll cut that and put you in the fave category. Oh. This is a controversial one. This is the binomial function. I used to be, at a point in my life, employed by a lottery company. So, the binomial theorem and this function in particular were my meat and vegetables. Did a lot of calculation of probabilities using this and using it to work out chances and that type of thing. It's very powerful, very useful. So, partially it's my fave, but it's also, because of that, a function that was used for evil I'm not sure if I should, so it should be a no. If we balance these out, I'm going to have to put you into maybe. You are going into maybe. Because your power for evil is almost as great as your powers for good. Now, this is I'm just going to have to look at my notes here. Yeah. The Dirac delta function. This function's creepy. This function, when you draw it on a graph, gives you a point that is infinitely high, has zero width, and has a finite value when you integrate it. It's downright disturbing. It shouldn't exist. Yes, I know it's really important in signal processing, and it's really important for all of those mathematical functions and all of those type of things. But damn, it's spooky and weird. I don't trust it. You are going into no, and there we have it. My favourite functions, the functions I would say yes to, the functions that you're going to have to persuade me about, and the functions that just squick me out. Thank you, everybody.